We're starting off chapter 4 with this example. We're going to be classifying triangles by sides and by angles. If we look at the ways to name triangles in terms of their sides, there is scalene, isosceles, and equilateral. In terms of its angles, we can have acute triangles, right triangles, obtuse triangles, or equiangular triangles. So we look at this triangle. I don't know if you can see it, so I'll try to zoom in as well. If we look at the triangle that's shown in this picture, if you look, there's two markings here that shows that this triangle is an isosceles triangle. And I don't have a protractor, but it looks like all three of these angles are less than 90 degrees. So it should be an acute triangle as well. And looking at the answer, again, it has a pair of congruent sides, so it's isosceles, and measuring the angles, it's an acute triangle, so we would state that this is an acute isosceles triangle. If we get a problem like this in example 2, it says to classify the triangle by its sides and determine if it's a right triangle. In order to classify it by its sides, we need to measure the length of each side, which means we need to use the distance formula. We're going to use that 3 times. So I'm not going to write it out for this one, but we use the distance formula to find the side lengths. We have OP, which is square root of 5 or 2.2. We have OQ, which is rad 45 or 6.7. And we have PQ, which is rad 50 or 7.1. Now all 3 sides are different lengths, so we would know this is a scalene triangle. In order to find the whether it's a right triangle or not, we would look at 2 sides, the 2 sides that look like they might be a right angle, and we look at the slopes for PO and OQ. So we're going to do that next. So OP has a slope of -2, and OQ has a slope of 1/2. If you notice, these are opposite reciprocals of each other, so therefore they form a right angle, and so therefore, since those are perpendicular, POQ is a right angle, and we have a right triangle there. So in this case, triangle PQO is a right scalene triangle. Here they're going to ask you to draw different types of triangles, so it needs to be obtuse and isosceles, and then we're going to draw one where it's acute and scalene. So obtuse, isosceles, if you notice, these 2 sides are equal, and this is an obtuse angle right here, angle B. For an acute scalene triangle, would look something like that, although this looks like it's more than 90. You would want to make sure that all 3 sides were different, and that all 3 angles were less 60 degrees or less. And for this last one, it's very similar to the other example that I showed you. So to classify by its sides, I'm going to find AB, for example. And AB, we have 3 minus 0 squared plus 3 minus 0 squared. That gives me the square root of 3 squared plus 3 squared, which is equal to the square root of 9 plus 9, or the square root of 18. Of course, that is also the same as 3 rad 2. For BC, here we have -3 minus 3 squared. Whoops, I'm sorry, -3, yes. -3 minus 3 and -3 minus 3 squared. This gives me the square root of -6 squared plus this, plus -6 squared. That's the same as 36 plus 36, which is square root of 72, and that ends up being 6 rad 2. For AC, we have the square root of negative 3 minus 0 squared plus negative 3 minus 0 squared. That's the same as negative 3 squared plus negative 3 squared. That's going to equal, again, the square root of 9 plus 9. And if we look up here, it's also the same as 3 rad 2. If you notice, two of the sides are 3 rad 2. The third side is 6 rad 2. That means that two of the sides are equal. That means it's isosceles. Now, since I don't have the graph with me, if you wanted to, you could graph this, but I'm just going to look at it and see for different lines what the slopes are. For AB, the slope is going to be 3 minus 0 over 3 minus 0. So the slope here is 1. For BC, it's going to be negative 3 minus 3. Oops, I'm sorry, I messed up there. Let's see. I made a big mistake. Let's see. So we had negative 3 minus 3, and then 3 minus 3. Sorry about that. It doesn't really make a difference. So we'd have, second one, we'd have 3 minus 3. This gives me a 0 here. I apologize. The answer is still the same in this case. So we would have plus 0, that's square root of 36, which is 6. So in this case, we know that it's still isosceles. So for the second one, we've got negative 3 minus 3, and then 3 minus 3. That gives me, whoops, I'm sorry, I've got that the wrong way. Let's see, we've got 3 minus 3 over negative 3 minus 3. That gives me 0 over negative 6, which gives me 0. And then for AC, we've got negative 3 minus 0 and 3 minus 0. That gives me a negative 3 over 3, which is negative 1. If you notice, these two lines are perpendicular because they're opposite reciprocals. So therefore, there is a right angle and it is a right triangle. And therefore, we can say that it's an isosceles right triangle because two sides are the same, making it isosceles. Two slopes are opposite reciprocals, so that makes it isosceles as well. So, I'm sorry, a right triangle. So it's a right isosceles triangle. And that's it. Thanks.